Hello friends. In this video, we'll get acquainted with the new multi-protocol network gateway SMlight SLZB-MR1. This unique device deserves special attention, as it is the first production gateway to combine two powerful radio modules from different manufacturers. Texas Instruments CC2652P7, a popular zigbee/thread module with a power amplifier and stable operation in large networks. Silicon Labs EFR32MG21, a versatile chip supporting Zigbee, Thread, and Bluetooth, with a strong reputation in matter-based devices. This combination of modules allows simultaneous use of different protocols, Zigbee and Thread, making the SLZB-MR1 one of the most flexible and promising smart home solutions on the market. While preparing this review, I realized that the material was too extensive for a single video. So I decided to break the review into several parts. In the first part, we'll examine the appearance and construction of the device, take a look inside, and understand its hardware components. We'll explore the device interface. Note that the logic is handled by a separate ESP32 chip, and the manufacturer has developed a truly functional system called SLZB-OS, with many features including switching operating modes, updating the firmware of both radio modules, and even scripting and automation capabilities. And finally, we'll add native home assistant integration for working with SMlight devices. More on that shortly, but before we start, please support this video with your likes and subscribe to my channel so you don't miss new reviews and tutorials. Model: SMlight SLZB-MR1. Device type: multi-protocol network coordinator. Interfaces: Zigbee, Thread, Bluetooth, Wi-Fi, Ethernet, Matter support. Power: USB-C or power over Ethernet 48 volts. Radio modules: CC2652P7 and EFR32MG21. Control module: ESP32. Adapter dimensions: 160 by 24 by 28 mm. Antenna dimensions: 195 by 12 mm. The device comes in a branded cardboard box. As I've mentioned in past reviews of similar devices, each model has its own color scheme. In this case, the box itself is also larger. On the back, you'll find brief technical specifications for the device, which I've already covered, as well as a list of included accessories. Box contents. Unlike previous versions of SMlight network coordinators, links to their reviews are in the description. This new model includes two antennas, one for each radio module. Besides the two antennas and the coordinator itself, the package also includes mounting accessories, as usual, a pair of screws with a hex key and a small piece of double-sided tape. The first external difference in the SLZB-MR series, and at the time of the video, models SLZB-MR2 and SLZB-MR3 had already been released, is the presence of two antennas, one for each radio module. In other respects, the design is similar to previous versions with a single module. On one of the narrow sides, there's a network port, which can also be used for power over Ethernet, 48 volts. If you don't have a post switch or injector, power can also be supplied via USB-C. This port can also serve as one of the interface options for connecting to a smart home server. Although, in my opinion, this is not the best use for a network coordinator. On the top of the case, there's a single multifunction button, which is used to switch modes and perform resets. I was very interested in taking a look inside the coordinator. The case is easy to open. The bottom cover is secured with clips and can be removed using a flat screwdriver. Here you can see the CC2652P7 radio module from Texas Instruments. This is a modern multi-protocol SoC system-on-chip that supports Zigbee 3.0, Thread, and BLE. The P7 version uses 256 kilobytes of RAM and 704 kilobytes of flash memory. And this is the ESP32 from Espressif, a dual-core microcontroller with Wi-Fi and Bluetooth support, which is used here as the main control unit of the gateway. It manages interaction between the radio modules, interfaces, and software stack. In the upper right corner is the MUX1574 chip from Texas Instruments, a 4-channel analog multiplexer/demultiplexer with digital control. It handles switching between interfaces, for example, toggling USB left-right arrow UART depending on the mode, firmware upload, debugging, normal operation. This allows a single USB-C port to function as a universal connector. Interface section. The CP2102N chip serves as a USB UART converter, and the MUX1574 multiplexer, as mentioned, manages switching between modes. On the right, there's an SII RDC controller with a 50 MHz crystal, likely for precise synchronization or extended control features. On the other side of the board is the second radio section of the SLZB-MR1 coordinator, based on the EFR32MG21 module from Silicon Labs. This SoC supports Zigbee 3.0, Thread, OpenThread, and Bluetooth LE. This module functions as a second, fully independent radio interface from the CC2652P7, allowing for parallel operation with two stacks or networks. For example, Zigbee plus Thread. Here you can see the power section of the device. Two ABS 210 diode bridges provide reverse polarity protection, and a switching regulator with an inductor delivers the necessary supply voltage. Also visible is the 24C02 EEPROM for storing configuration data. Appearance with antennas attached. In this form, it resembles a small battle droid from Star Wars. Compared to the SLZB-06 series, the body is somewhat shorter and the antenna mounts are placed on the sides, which also shortens the overall length. Now it's time to move on to connecting. I use the LAN interface for both data transfer and power. For this, I use a managed PoE switch from SteamMO. There's a link to the review in the video description. By default, the coordinator is set to automatically obtain an IP address, so after powering it on, you'll need to check your router's network map to see what address has been assigned. I open the address in a browser and first go to the Settings and Tools section, Firmware Update tab. Here, I select to check the core firmware. This screen shows the current and latest available firmware versions. At the time of testing, the latest version was 2.8.7. Selected. The process is completely automatic. The firmware is downloaded and installed right away. In some cases, the update may happen in several steps if the pre-installed version is too old, so it's best to check again after updating. Once installed, the device automatically reboots and displays a changelog for the new firmware version at startup. Now let's examine the device interface. With each new version, it gains additional functionality and can now rightfully be called a mini operating system. On the first page, we see key information. Currently, both radio modules are operating in Zigbee coordinator mode, and the connection type is Ethernet, the most stable operating mode. On the right column, information about the radio modules and the control module. We just updated it, so the last check date is shown. We'll get to the radio modules soon. Further down this same page, additional information. The status of Zigbee Auto Update Mode, VPN, and network details. In my case, the device is running over Ethernet and obtains its address automatically. Wi-Fi is disabled. The second tab, Operating Modes. Each radio module supports 3 modes. By default, Zigbee Coordinator is selected. You can also set either module to Zigbee Router mode or Matter over Thread. I will test this in later parts of the video. Below, the baud rate, which is 115,200 by default, and the port numbers. Naturally, they differ for each radio module. Further down, an option to enable Bluetooth proxy via ESP Home, either as a standalone feature or alongside Zigbee/Thread. This is convenient for Home Assistant if you want to expand BLE device coverage, e.g., thermometers or trackers, without installing additional gateways. Important, the ESP Home firmware in this mode doesn't have a web interface, and it can only be managed through Home Assistant. The Ethernet to Wi-Fi bridge mode is designed to extend Wi-Fi coverage specifically for IoT devices. The coordinator creates an access point and forwards all traffic via Ethernet. Useful if it's installed in a location without Wi-Fi, but with cable access. This mode does not replace the main router and is intended for connecting low-load devices like smart sensors and relays. Below it is the operating mode switch. Ethernet is optimal, and if it's not available for some reason, fallback options are Wi-Fi or direct USB connection. Next, network settings. Here, you can enable or disable IPv6 and MDNS support. Activate the SSE server on port 80. Note that Home Assistant integration via SMlight SLZB won't work if this is enabled. Below, network settings, starting with Ethernet. DHCP is enabled by default, allowing the coordinator to automatically get an address from the router. However, keep in mind that integrations and add-ons will refer to the device by its address, so it must remain constant. Either reserve the IP in your router settings or manually enter it here by disabling DHCP. Wi-Fi settings, similar to Ethernet, except there is an option to scan for available networks. It only works on the 2.4 GHz band. I recommend using this mode only in extreme or fallback scenarios. The next tab, third-party app settings. Unlike single-module devices, the MR1 has two panels on this page, one for each module. The first listed is EFR32MG21, with port 6638 by default and adapter type ESP for Zigbee 2 MQTT. The second is CC2652P7, with port 7638 and adapter type stack. Similarly, settings for ZHA integration. By the way, a good use case for this device is to run ZHA on the EFR32 module and Zigbee 2 MQTT on the CC2652P7. And here are the settings for USB operation. The port addresses must be checked in your server settings. Personally, I find this the strangest use case for such a device. I should also clarify, only one operating mode can be active at any given time. You cannot, for example, connect ZHA via USB and Zigbee 2 MQTT via the network simultaneously. Further below are the radio module settings. Here, you can change the default ports, though I can't think of a scenario where that would be necessary. You can also set the port speed here. By default, it's 115200, and you shouldn't change it unless you have a deep understanding of why and what will happen as a result. This section handles advanced socket settings for the Zigbee chip. Zigbee socket packet processing enables a mode where the device itself assembles protocol frames, EZSB or ZMP, reducing load on external clients, but other types of traffic won't be passed. Multi-threaded socket connection allows up to 5 clients to connect simultaneously, but only one can actively communicate with the Zigbee chip at any time. Others will wait. Multi-radio queue control manages queues if multiple radios, e.g., Zigbee and Thread, are active, preventing conflicts during data transmission. These options are useful in advanced scenarios, like working simultaneously with multiple Home Assistant instances, external bridges, or custom applications. This section lets you change the IEEE address of the Zigbee adapter, the unique identifier by which devices recognize the coordinator on the network. If you're migrating from another adapter, for example, based on the CC2652, device repairing won't be necessary if you follow these steps. Turn off Zigbee 2 MQTT/ZHA and the old coordinator. Disconnect power from all Zigbee routers for at least 15 seconds. Power on the routers, then the new SLZB-MR1. Start Zigbee 2 MQTT or ZHA. Wait for devices to rejoin the network, sometimes up to 10 minutes. If devices fail to reconnect, you can manually assign the previous IEEE address to the new coordinator. Important, these features don't work in USB mode. Make sure to stop the Z2M/ZHA integration before proceeding. For my part, I've migrated devices between coordinators many times, never powered off the routers, and everything always restored correctly. Below is a menu where you can read the current IEEE address, and in the case of the CC2652P7, also the factory set one, as well as enter and write a custom address. So, if you're migrating from an old coordinator, it's a good idea to save its address just in case, so it can be entered here later. But again, I've done many such migrations and never needed this. However, they were always between devices using radio modules from the same manufacturer. The security section provides basic protection for accessing the interface and coordinator socket. Here you can disable the web interface when a socket connection is active, e.g., with Zigbee 2 MQTT. Enable login password authentication for the interface. Define an IP whitelist. Only those addresses will be allowed socket access. Set a password for the fallback access point, fallback AP, in case the gateway loses connection to the main Wi-Fi network. The VPN section lets you configure a secure connection from the coordinator to a remote home assistant server using WireGuard. Here you can enable the VPN and specify the local IP. Generate a private key and optionally set a pre-shared key. Enter the address and port of the WireGuard server. Enter the remote peer's public key and optionally enable ping checks for connection monitoring. This feature is especially useful if the coordinator is installed in a remote network, for example, at a summer house or a parent's home, and you want centralized management. This is a relatively new feature added to the coordinator interface, or rather, to the device's operating system. It allows creating local scripts and automations that will execute directly on the coordinator. There's documentation for this available on the manufacturer's GitHub. I'm still studying its capabilities and plan to make a separate video with usage examples in the future. For now, let's continue exploring the device interface. The General Settings section lets you assign a name to the device, e.g., SLZB-MR1, which will be visible on the local network. You also have options to enable anonymous telemetry, only ID, model, and firmware version, restart the Zigbee module, enter flash mode, fully reboot the device, and calibrate the internal temperature sensor, which requires an accurate room temperature reading and at least 10 minutes with the coordinator powered off. The firmware section, we've already visited this early on when I updated the ESP32 system core. Now, let's handle the radio modules, starting with the first one, EFR32MG21. I click the check button. First, it shows the current operating mode, in this case, Zigbee Coordinator, since each mode has its own firmware version. The factory firmware version was from October 30th, 2023. That's what the numbers represent. The latest available version is from February 20th, 2025. Important, when using this version with Zigbee 2 MQTT, you must specify the adapter type as Ember instead of ESP. Next, everything happens automatically. The latest firmware version is downloaded from the internet. Then it's installed. Very convenient. No need to search for anything, worry about which version is compatible with your module, or figure out how and where to flash it. The manufacturer has already taken care of everything. Done, the updated version was successfully installed. The coordinator does not reboot during this. While updating, any system using that radio module will be offline, but everything will resume afterward. Same for the CC2652P7 module. The factory installed version was from March 16th, 2024, and the current version is from March 25th, 2025. Let's install it. Wait a few minutes while it downloads and installs. Everything is automatic, no extra action needed. All done. The current firmware versions and their check dates are now shown on the main dashboard tab. Back to the previous screen. Below the manual firmware check/update menu, there's a setting that enables automatic firmware checks and updates. My recommendation, manage this manually and only update by hand. LED control menu. The manufacturer even thought of this detail. You can turn them off entirely or only at night, with options to set the start and end time. Time settings, time zone, and NTP servers. In my case, everything was correctly pre-configured out of the box. The log and debug section provides access to the system log. It displays key events like firmware start, configuration loading, reason for the last reboot, and initialization of serial ports for the Zigbee radio modules. Additionally, you can clear the console or manually send a command to the Zigbee module in hexadecimal format. As you can see, we've only just reached Home Assistant, and the video is already quite long. So I'll cover usage scenarios and device testing in the next part. For now, we'll only look at the native integration for monitoring and managing the coordinator itself. This is one of my test servers. I've intentionally reset it to a near-default state to demonstrate everything from scratch. Open the Settings menu, then select Devices and Services. This is also where the Integrations tab is located. It starts by offering to install integrations for devices that have been automatically discovered on the network, including the star of this review. The manufacturer created a dedicated integration, SMlight SLZB, which is already part of Home Assistant. There's nothing else to install. It detects the newly available SLZB-MR1 device. Click Add and confirm your intention to install the integration for this device. If needed, you can specify a location or skip that step and finish the installation. Done. The SMlight SLZB integration for our MR1 coordinator is now installed. By default, it displays 25 entities. If you have several coordinators from this manufacturer, repeat these steps for each one. This is what the device page looks like. On the left, the name, firmware version of the coordinator, and the first radio module. I expect the second module to appear here after its update, and MAC address. In the middle column, 2 toggles for controlling the LEDs and night mode, firmware version check entities, meaning you can update it right from Home Assistant. There are also buttons to restart the system core and the radio module. In addition, there's a variety of system information, connection type and status, temperature of each SoC, radio module operating modes. The integration is designed so that all major options and system info are visible here, which is more convenient than having to log into the device interface. That's the end of part 1 of the review. I think there's more than enough information for a single video. The concept itself is very interesting, combining 2 coordinators in one device and on modules from different manufacturers, which enables using different integrations or even different protocols simultaneously. And the price of a single such unit is lower than buying 2 separate ones based on equivalent modules. I hope the information in this video was interesting and useful to you. I'd appreciate your likes. They help the channel grow on YouTube. If you don't want to miss new videos, please subscribe. You'll find links to all mentioned resources, my Telegram channels, social media accounts, and smart home discussion groups in the description below. Feel free to join. It'll be interesting. Thanks for watching. See you next time. Peace to all.